It's not uncommon for members of the public to have questions about radon. Radon in your basement is a big one. That's what this person's asking about right here. It's a simple public query on, can you give me more information about radon? And yeah, I would love to. So the only parent that naturally creates radon is radium. So if you have any radium in your soil, when it undergoes radioactive decay, it gives off an alpha particle, which is a helium nucleus, so it emits helium. But the other part of that decay process is radon. So when radium decays, it decays into two gaseous atoms. And the radon is a noble gas. And because it's a noble gas, it really doesn't bind with anything. And so if that radium, when it decayed, was near the grain boundary of whatever mineral or dirt speck that it was in, if it's near the grain boundary, it can diffuse along that grain boundary and get into the interstitial air volume of the dirt that's in there, of the soil. And when that happens, being a noble gas, it just diffuses like a noble gas. And if it's underground, it's just going to diffuse underground. And if it runs into a basement, if there are cracks in that basement, it will diffuse through that crack and into your basement. Now, the radon from uranium decay series, that radon has a half-life that's about 4 days, so it hangs around for a while. And what that means is if it gets into your basement, it's going to take 4 days for it to decay away, or at least for half of it to decay away. And the funny thing is, it's really not the radon that's an issue per se. It's actually the decay products from the radon. The radon will decay through a number of other heavy metal radioactive isotopes. And those are what's concerning. And the reason why is when I breathe in radon, it's still a noble gas. And as a noble gas, it pretty much just comes in and comes right back out of me. And it doesn't do a whole lot. It takes 4 days for half of it to decay away. So the amount of time it spends in my lungs when I breathe it in isn't a whole lot. Now, if I spend a lot of time in a radon environment, then I'll increase my dose. But the biggest concern are its decay products, because it's a noble gas, radon, but when it decays, it's going to give off heavy metals. They're going to be charged, and those heavy metals are no longer gases. I mean, they start off as a metallic gas, but those will attach to progeny in the environment, and those progeny in the environment, not progeny, sorry, the aerosols in the environment, the progeny will attach to aerosols. And those aerosols, those will be the things that I breathe in. Now, some of them, if they're small enough, they can get down into my lung alveoli, and they can pass the barrier, the lung to blood barrier, and get into my blood directly. Alternatively, if my filtration system in my lungs filter that, then those radio aerosols will attach to the mucus lining, and the cilia in my lungs will push it all up. And if I don't spit it out or cough it out, if I swallow it, then I ingest it, and now it goes through my digestive tract. And so it's the progeny that's an issue. The progeny can attach to aerosol, and if it doesn't, if it remains in the gaseous form, then it can still pass through the blood barrier as it gets into your lungs. So it's really the progeny, the radioactive decay products of radon, that gives you the dose. And all of that probably was way more physics than you wanted. What you might have wanted to know was just as long as you have some kind of ventilation, you can get the radon out. That's how it actually happens in nature. The radon in the morning is going to be something like 2 times higher concentration than you have in the afternoon. And the reason why is because in the morning you have a natural temperature inversion just due to the black body radiation that's occurring from the Earth at night. You actually end up having a temperature gradient that causes the temperature to actually rise as you go up, because the Earth is continually doing black body radiation, and the air that's touching that is going to actually get to a lower temperature as the Earth gets lower. But it takes longer for conduction to do much up in the as you get higher in the atmosphere, because it's a gas. But when a gas is touching a solid, you get more conduction. And so it's called an adiabatic lapse. An adiabatic lapse rate, the fact that you have black body radiation from the Earth, you don't get quite as much from the air because it's a gas versus a solid. Now, all that to say that you get more radon in the morning than you do in the afternoon due to these natural temperature inversions that occur. And so why they go away in the afternoon is that when the sun hits the ground, you're going to get some convective currents that start to take place, where the heat from the Earth receiving the solar insolence causes the Earth to heat up. It causes convection currents in the air. Those convection currents rise and they break the temperature inversion, and they cause the dilution. The radon near the surface of the Earth gets diluted in the upper atmosphere, making the radon levels here where we breathe much lower. And so all it takes is just ventilation, just taking the radon and putting it someplace else, and you mitigate that issue. That's how nature does it, and that's basically how we do it in our own homes. We just do the same that nature did. We just do it with a pump. So that's how you get rid of radon. Or you can try to seal all the cracks in your basement to prevent any from leaking in. But I probably already gave you way more physics, or I guess that's health physics, way more health physics than anybody really wanted to hear. So I hope you liked it. I hope you enjoyed the video. Everybody that learned something found that fascinating, and I hope you all have a great day. Thanks for watching.